Welcome back to my new video. So in this video we have a topic analog and digital electronics. These are the two types of electronics. As in the last video we discussed about the introduction, we discussed about the introduction to electronics. So today we will discuss about the analog and digital electronics. So firstly let me remind you what is electronics. Electronics means a flow of charges controlled, which are controlled. Okay, so now let us come on our topic, which is analog and digital. So in analog, we can say in analog we study about the analog quantities. In analog electronics we study about analog quantities. We can say it is continuously changing values, uh, continuously changing values, or variations coming, or we can say variations coming, continuous variations. Okay, so in analog quantities we discuss about the analog electronics, we discuss about the analog quantities, which means a continuous changing, coming a continuous change in a minute in a values, or we can say variations coming, continuous changing variations. So in for taking example of analog quantities, so if in the morning, for example, taking an example of temperature, in morning, for suppose we have a temperature 10 centigrade, but when we see in the afternoon it becomes 30 centigrade. So from 10 to 30, when it is coming from 10 to 30, it's continuously changing, like 10.1, 10.2, 10.3. Same way, like continuously changing, it becomes 30. So that is we can say coming in the analog quantities. But in digital quantities, in digital electronics, we discuss about the digital quantities. So in digital quantities, if in the morning the temperature is 10 centigrade, and in afternoon the temperature becomes 30 centigrade, taking the same values. So here we can see in the morning 30 centigrade, and in the afternoon afternoon 10, and afternoon 30, and morning 10. So when it's changing temperature, means temperature changing means suddenly a temperature change. When we are skipping the mid values, means 10.1, 11, 12, 13, 14, we all skip the values, we are skipping these all values. So this is called the digital quantities. When we are skipping, we are coming into a sudden change. When there is a sudden change in the values, when there is a sudden change in the signals, so in that we will discuss about, that is called the digital quantities, coming a sudden change, we can write sudden change. Sudden change is digital quantities. So as taking more examples, so you can take example of clock. We have two types of clock, one is analog and one is digital. Which one is analog, which one is digital? So in analog, we can say, let me make a diagram. So one, we have two types of electron not we have two types of clocks, analog and digital. So we have two types of clock. A clock which is having three arrows, one shows the seconds, one shows the minutes, and one shows the hour. So in this clock, it's continuously changing. For suppose it's a arrow for seconds, it's arrow of second. So it's continuously changing, means that if the time is 2 p.m., so 2 p.m. Means 2 hours 1 minute, 2 hours 2 minutes, 2 3, 2 4, 2 5. It's continuously giving a change, it's continuously giving a variation in its time, it's continuously changing the value. But in this clock, you can see it's a direct, we are seeing the value, we are direct watching the values, means 6:10, when it becomes 6:11, 6:12, 6:13, means this is a sudden change, a complete or a sudden change in a time, sudden change in a value. We are skipping 10.1, 10 minute 1 second, 10 minute 2 second. We are skipping those values and directly coming to another value, giving a sudden change. So that is comes into a digital. So this is an example of digital. and this is the example of analog. Okay, analog. So in digital, mostly we will discuss about, we study about the we can say abrupt quantities, means coming in a sudden change. Abrupt quantity means abrupt quantities means a suddenly change sudden change or suddenly coming change in any value, in any quantity, in any signal. That is that we study in the digital quantity. So now we will see the graph of digital and analog, or digital and analog. So if, for example, I'm making a graph. Okay, so here temperature and here is time. Okay, this is the temperature, this is the time. For example, the temperature is here, we have 0. it's it means it increasing the temperature, increasing, then again decreasing. When it's decreasing, again increasing, and again decreasing. So that is, we can say, analog graph. When it shows a complete change, every changing point, every changed point is, means this graph you can see it's show from, this is a 0 centigrade, this is 1 2 3 temperature, this is 10 centigrade. So this is showing a exact value, exact, we can say, each and every point, how, when it's change, how it's decreased. You can see here, means in this graph we can see the each and every point. But in digital graph, let me make a digital graph. Time and temperature. So here you can see 4 volt, this is 4 and this is 2. Okay, so if a temperature start from 4 centigrade, this you can see, this is a exact line, it's an exact line, a straight line. So in this we can say it's, the temperature is not changed, it's a 4, means we have a 4 centigrade, 4 centigrade temperature. And if it change into a sudden value, it becomes 2. When it becomes a 2, so this is, means it's not showing each and every point. 4 and directly jump on 2, 4 2, then again it's going time, again it's become 4, again 2, again 4 2. So this type of graph is, we can say, in a form of digital graph, when it's showing, not showing an exact value, not showing each and every point of changing, each and every point of variation, but only showing a exact point from 2 to 4, 4 to 2, 2 to 4. Not means 2.5, 2.3, 2.8, 3, 3.5. It's not showing each and every point, but showing an exact point, how it's changed. So this can come into a digital, and this comes into a analog. So in analog, we can, sometimes we are saying digital is more accurate in an analog. In analog we do measurement, in analog we do measurement in analog we do measurement. In this digital we do counting. Means, in why we are doing counting, we have an exact value, we have an exact value, means 11 12 13 14 or 20 to 40, we have an exact value, so we can count. And in measurement we are measuring the values. So in measurement we can have sometimes a mistake, but in counting we don't have mistake, we cannot make a mistake in counting. But in measurements, by measuring the quantities, by measuring some values, we can have some mistakes, but in counting we don't have. So in this way we are saying that means digital is more accurate than analog, and digital quantities are more accurate than the analog. So that is all about today. So see you in the next video.